Hey everybody, this is Mr. Gordius, and we are going to be doing systems of equations today by the elimination method. Okay, so take a look at your objective right here. Make sure you copy that down. I can solve systems of equations by adding or subtracting the two equations to eliminate a variable. Okay, so now when we're doing systems of equations, our main goal is to eliminate one of the variables. So before we did that by substitution, and today what we're going to do is we're going to do that by what's called the elimination variable, where we're literally going to combine the two equations to eliminate one of the variables. Okay, so first thing is here are all your steps to systems of equations and solving systems. Okay, so step one is to write the system so that the like terms with the same or opposite coefficients are aligned. Okay, so we want to set it up so that we can eliminate something. Okay, step two is then we're going to multiply, if this is only if necessary, we would multiply one of the equations by -1 if necessary, so that there is at least one variable with the same coefficient and opposite signs. So our goal is to have something like a positive 2x and a negative 2x aligned together so that when we combine these, they will eliminate each other. Then we solve, then we substitute. Get this copied down, and then when I show you an example, I promise it'll make more sense. Okay? So here I have a system. Negative 3x minus y equals 8. 7x plus y equals negative 12. So before, what we did is we did the substitution method. We would solve for a variable and then plug in that variable into the other equation to solve. With the elimination method, what we're going to do is step one, we're going to write the system so like terms with the same or opposite coefficients are aligned. So right now my coefficients are aligned. I have my x is my first term, my y is my second term, equals some solution right here. So that was step one. All my coefficients are aligned, all of my variables are aligned. Now what I'm going to do is step two says multiply one of the equations by -1 if necessary, so that one of the variables with the same coefficients has opposite signs. Well, I don't need to do that, because what's going to happen is my ultimate goal in solving systems is I want to add the two equations together. And if I add them together, my goal is to eliminate a variable by adding. And if I look at this, I have a negative y here and I have a positive y. If I add negative y with positive y together, they cancel each other out. I eliminated the y's. So now I can add negative 3x, positive 7x together. I'm combining them. That's going to give me a 4x. I'm also combining 8 and negative 12, which is going to give me negative 4. So by adding both of these equations together, I'm just adding. That's why I lined them up first. Then when I add them together, I eliminated my y's, and now I have a simple 4x equals negative 4. Now I can solve by dividing by 4. X equals negative 1. So that was step 3. I solved the equation. Step 4, I take my solution right here, and I take it and I substitute it back in to one of my original equations. It doesn't matter which equation I substitute it back into. It's really personal preference. So I'm just going to use the first one. So I'll use negative 3 times negative 1 minus y equals 8. This becomes positive 3 minus y equals 8. Subtract 3 from both sides. Negative y equals 5, which means y equals negative 5. So my solution to this systems of equation is negative 1, negative 5. And that is where these two lines intersect. So let's do another one now. So I have negative 3x minus 5y equals negative 7, negative 4x plus 5y equals 14. Lucky for me, these are already nice and lined up, so I don't have to move anything around. Now I can now I need to look to see if I add these two equations together, will something be eliminated? So if I add these together, will I eliminate a variable? Well, I won't eliminate an x, but it looks like I might eliminate a y, because I have a negative 5y, a positive 5y. So if I combine these two equations to make one, negative 5y plus positive 5y, they do eliminate. Negative 3x plus negative 4x, negative 7x, and then I have negative 7 plus 14, which is equal to 7. Divided by negative 7 on both sides, x is equal to negative 1. Okay, now that I have my x coordinate, I know my solution somewhere is going to have my x value is going to be negative 1, so now I've got to figure out what my y value is. I can just go ahead and plug that in. So let's use the second equation this time. So I have negative 4 times negative 1 plus 5y equals 14, which will give me 4 plus 5y equals 14. Subtract 4 from both sides, I'll have 5y equals 10. Divide both sides by 5, which will give me y equals 2. So my solution to this system is negative 1, 2. Now let's look at something that might be just a little bit different. So now I have x plus y equals 1, and I have negative 2x plus y equals 4. So with this one, if I were just to add these equations together, I will not be able to eliminate anything, okay? Because if I add the two y's together, that'll give me y plus y is 2y, x plus negative 2x is negative 1x. So nothing's eliminated. So what I'm going to do, though, is this is that step 3 that we talked about earlier, the step 2 that we talked about. I'm going to multiply one of the equations by negative 1. And then when I do that, that's going to change my y to negative y. And that way I can actually eliminate something. So I'm going to multiply this equation right here, this whole entire equation, by negative 1. Okay, let me get rid of this. Why is this here? There we go. So I'm going to multiply this whole equation by negative 1. Okay, and let's make this look a little bit better by putting this over here so it looks like the distributive property. So it is the distributive property. I'm going to do negative 1 times x, negative 1 times y, and negative 1 times 1. So that makes this negative x, negative y, negative 1. I just changed the sign of every single piece on both sides of the equal sign. Now when I combine these two equations, I will eliminate my y's. My positive y and my negative y will cancel each other out. And I can add them together, and I'll have negative 2x plus negative x is negative 3x equals 3, x equals negative 1. Now I can go back and plug it into any of these original equations. So let's just use the second one right here. I'll have negative 2 times negative 1 plus y is equal to 4. Negative 2 plus y is equal to 4. Add 2 to both sides. Y is equal to 6. So my solution is negative 1, 6. One more example just to make sure that we've got it. So I've got 2x minus y equals 7. 2x plus 7y equals 31. So again, if I add these together, if I combine these, I'm not going to cancel anything out. I'll have 4x, I'll have 6y, I'll have 38. I need to eliminate something. So what we're going to do is let's just multiply any equation. It doesn't matter which one I multiply by negative 1, but I'm going to distribute a negative 1 to this top equation. And that's going to give me a negative 2x positive y equals negative 7. I just changed my sign. So positive 2x became negative 2x, negative y became positive y, positive 7 became negative 7 by using the distributive property. Okay. Now I can add these two, combine these two equations. I can to cancel out my x's right here, because 2x minus 2x plus negative 2x, those cancel each other out. Now when I combine my 7y and y, I'll have 8y. 31 minus 7 is 24. Divided both sides by 8, my y is equal to 3. Now that I have a y, I can take it, plug it into one of my original equations. Let's use this one right here. So I have 2x minus 3 equals 7. Add 3 to both sides. I'll have 2x equals 10, which means x equals 5. And that'll give me my solution of 5, 3. Okay guys, hope this video helped, and good luck. Thanks.